ready in my presentation. So this will be our last synchronous classes for discussion for this semester and for this final term. This will be our last module for 422 production planning and control. We will be focusing for today's discussion on module number 6, airplane corrosion control and aging aircraft program review. I have here around 30 slides, and hopefully we could finish it within an hour. So let's go ahead and start. Moving into our next slide, we got here the table of contents that we'll be discussing for today. We'll start off with the corrosion control, forms, factors, and how the corrosion actually form. We'll be moving on to some few notes on preventive maintenance, inspection, and we'll be discussing corrosion removal, specifically on ferrous metal, aluminum alloys, magnesium alloys. We'll get into the similar metal contacts, corrosion limits on how we categorize the corrosion damage on our aircraft, some chemical treatments, and a few quick discussion on aircraft aging program review. Next slide, we got corrosion control. So corrosion is one of the most damaging output of age and a poor preventive maintenance to an aircraft. If it is left unchecked, corrosion can cause an eventual structural failure. One example of this is an accident we have discussed last prelim. If you could remember, the Aloha airline accident in Hawaii. It's one of the turning point of giving a big factor or considering factor on corrosion nung nangyari yung accident na yun, 1988 if I'm not mistaken. So corrosion is a natural process which converts a refined metal into a more chemically stable oxide. It is the gradual destruction of materials by chemical or electrochemical reaction within the environment. So on the next, I think slide number 6, I have there a short video on how the corrosion occurs or the standard process occur. It is very important for us to listen and take note on that video. I have a video kasi pagka sa face-to-face, I usually explain it through the whiteboard. However, it's very hard to explain the process on the slide. So I downloaded a video from the internet na magiging basis natin and magiging basis nyo on how corrosion form. Next slide, I got here a picture of a 787. So you could see, dito lang naman, I just want you to see yung breakdown ng materials used, especially sa trend ng aircraft natin today. And as you could see, we still have steel component, aluminum, titanium. However, you could see na yung trend ng market or aircraft production, lumilipat na tayo on the composite side. Since the composite, hindi siya prone to corrosion. And I don't know if this trend will continue na composite ang trend natin with the materials. Kasi before, aluminum to aluminum. Before lahat, aluminum. We got aluminum skin, aluminum parts. However, ngayon, we're turning into composites. So there you could see the breakdown. of materials together with their percentage. This slide is for you to compare those materials. Next slide, we have types of corrosion. We mainly divide them into two types: the direct chemical attack and the electrochemical attack. Yung both of this attack, the process is the same. So yung process or yung video na tinutukoy ko, it will be on the next slide. The process of both of this attack are the same. However, sa direct chemical attack, from the word itself, self-explanatory, we got a direct chemical on the process. And on this type of corrosion, na-expedite yung process natin. Mas mabilis. So on the spot, the corrosion will occur and the metal will be eaten. Sa electrochemical attack naman po, dito yung slower process where you could see na dahan-dahan na nakakain yung anode and dahan-dahan kinukuha ng cathode yung electron. It's a slow corrosion process. Mainly ito yung familiar tayo. With the direct chemical attack, we should have a chemical on this to speed up the process. Example nito is spilled battery acid. Kahit hindi spilled battery, kahit yung fumes lang ng ating battery could cause slowly corrosion. As you can see on the right-hand side of the screen, this is an example of a battery compartment. So if you will look, especially in older aircraft, kahit sa mga kotse, if you will look on the battery compartment or dun sa side where the battery is stored, may mga signs tayo ng corrosion. It is due to the fumes or to the chemical na binibigay ng ating battery. Another example, flux deposit. Nanggagaling to if nagkakaroon tayo ng chemical changes. Example is when we join metal or two materials using a chemical process. Example nito is welding, brazing, soldering. Yung flux deposit niyan nakaka-cause ng direct chemical attack. Another example ng direct chemical attack is mga cleaning solution. Present yan, especially now, COVID-19 is still present in the industry. We clean our aircraft in a much shorter and mas maraming interval. So yung cleaning solution, you must always check the MSDS if this solution are applicable on the material of the aircraft para hindi tayo magkaroon ng direct chemical attack na corrosion. Ito yung attack na familiar tayo. This is the process when a ferrous metal ay nabasa. Meron tayong ditong dissimilar metal contact, fretting corrosion. This is the gradual change ng pagpalit ng electron from an anode to a cathode. And this process, I have a presentation on the next slide to be explained further para matatak sa atin. Very important, alam natin yung process ng corrosion. Let me go into the next slide for the presentation. Okay, I got the presentation here. A lot of notes to take in, a lot of ideas, so play it.
In an electrochemical cell, electrons liberated by oxidation of a species at one electrode flow through an external conductor to a second electrode, where they are consumed by a reduction reaction. The fundamental components in an electrochemical cell are anode, cathode, metallic path, and electrolyte. All four components must be present for corrosion to occur. Anode. Metal of the anode is oxidized, causing it to lose mass or corrode. Metallic path. The electrons produced due to this reaction travel to the cathode through the metallic path. Cathode. Reduction takes place at the cathode and electrons are consumed. Electrolyte. It is the electrically conductive solution that must be present for corrosion to occur. An electrolyte contains positively and negatively charged ions, called cations and anions, respectively. The iron electrode produces 2 electrons as it is oxidized. Electrons travel through the wire to the copper cathode. The electrons then find the copper ion in solution and the copper is reduced to copper metal. During the reaction, the iron electrode will shrink in size, while the copper electrode will become larger due to the deposited copper that is being produced.
Okay, we got the video presentation. You could see here yung transferring electrons. So we have two materials lagi. To form a corrosion. The other naman or the other materials hindi naman specifically na kailangan ganito yung ating setup. The setup was just put up para maging better yung understanding natin how the current flows through the two metals. So sabi nga, we have an electrolyte. So yung electrolyte pwedeng yan yung rain natin, nabasa yung ating metal. Yung metallic path, hindi naman kailangan lagi may metallic path. Pwede yung anode material and the cathode is magkadikit. So you could still process or a current or the transfer of electron can still be a process pag nagkadikit yung dalawang material. So we got the anode and the cathode. Yung anode, siya yung kinakain. So siya yung nagpo-form ng oxidation. Oxidation process po ito. Siya yung nababawasan ng mass. Nagbibigay siya ng electron. Pag nagbigay siya ng electron, oxidation process happen and the material loses mass. The other material naman po is the cathode. The cathode naman po, siya yung nag-gain ng mass na pupunta sa kanya yung electron. So, the cathode gain electrons and yung process dito naman ay tinatawag na reduction. So, reduction and oxidation. Oxidation, yan yung process na alam natin with the corrosion. Sa chemistry, ito yung tinatawag na redox process. If nadaanan nyo ng high school, redox, reduction, oxidation. And another thing, sir, paano natin nalalaman kung sino yung magiging anode and sino yung magiging cathode on the two material? So, nalalaman yun based sa nobility ng material. So, nobility refers doon sa chemical reactivity ng isang material. So, may mga iba-iba tayong material if you're looking into the periodic table. And each one of them have a higher nobility than the other or an equal nobility than the other. So, mostly yung mga mas mahal na material, sila yung mas mataas yung nobility. Example, gold, silver, copper, matataas ang nobility niyan, much stable sila compared sa other material. So pag i-compare natin sila sa mga iron, carbon, steel, yun naman yung much lower nobility. And pag sila nagkadikit, let's say the similar contact or the similar metal corrosion, automatically, of course, yung iron, carbon, or steel, yung magiging ating anode. Siya yung kakainin kasi mababa ang kanyang nobility. Si gold, silver, or copper naman, sila yung hihigop ng ng electron and mag-gain ng mass. So, gain of electron and gain of mass. Sila yung magsisilbing cathode doon sa redox process. And sila yung reduction, kanilang pupunta yung reduction. And that is compared palagi sa dalawang material. So, pwede namang si gold and copper. So, with gold and copper, of course, alam natin, mas mahal si gold, automatically, maiisip mo agad, of course, mas stable tong gold material. Kaya nga, present, mas mahal siya. Mas less common siya than the copper. So, pag sa kanilang dalawa naman, si gold ang mataas ang nobility. Si gold ang magiging cathode and si copper ang magiging anode. Pero hindi yon doon natatapos. So may mga instances na magkapalit sila as anode and cathode. Depende kung na-process na yung isang material. That perspective is sa raw material or looking into raw material. So pwedeng we have a raw gold, meron naman tayong processed iron. So we could interchange naman depending on the stability of the material, it will look into sa nobility nila. Next slide, we have a few forms of corrosion. These are a few forms only, so hindi ito lahat. These are the most common, especially on the aircraft or the aviation industry. First up is surface corrosion. Appears as a general roughening, etching, pitting of the surface of a metal, frequently accompanied by a powdery deposit of corrosion products. So this corrosion will sometimes, spread under the surface coating and cannot be recognized easily by the powdery deposit. A closer inspection, will reveal the paint or plating is lifted off the surface, a small blister which result from the pressure or underlying accumulation of the corrosion products. So, surface corrosion nangyayari to usually doon sa part kung saan heavily stress or mas mataas yung changes in temperature. Bakit po? Kasi pag mataas ang changes on temperature or stress yung surface na yon, madaling nasisira yung ating paint. So, ang paint po, hindi lang po tayo nagpe-paint ng isang aircraft or ng isang material just for the design or para mapaganda or mapaganda yung isang aircraft. Naglalagay din po tayo ng paint as a form of protection. So pag may paint tayo, naka-cover ito doon sa ating metal. Pag may covering si metal, hindi ka magkakaroon ng redox process. Wala kang direct current to transfer the electrons. So yun yung use or one of the primary uses of the paint. However nga, sabi ko nga, may mga parts tayo na heavily stressed and mataas yung temperature. At as the time goes by, wear and tear, madaling masira yung mga parts na to, nawawala or nasisira yung paint natin doon or nalilifted. Pag nasira yon, magkakaroon na ngayon ng bare part yung ating surface which can proceed or leads sa process ng redox and can form surface corrosion. Next is the similar metal corrosion. Occurs at the point of areas or contact where the insulation between the surface has broken down or been omitted. So ito na nga, ito yung direct na makikita natin kanina doon sa ating presentation. Meron tayong dalawang dissimilar metal. It's nagsisilbing anode and nagsisilbing cathode. Ngayon, siyempre sa isang aircraft, kanina nga rin sa isang slide natin, I think slide number 4, you could see na magkakaiba yung parts na ginagamit natin within the aircraft. So doon sa mga parts kung saan nagiging connect or nagkakaroon tayo ng connection ng magkaibang material, may mga mitigation naman tayong ginagawa dyan, like naglalagay tayo ng rubber material or naglalagay tayo ng insulation doon between the two surface. However, due time nga din, wear and tear, nasisira yung insulation na yon and hindi agad na nakikita or na-inspect. Nagkakaroon tayo ngayon ng contact with those two dissimilar metal which could lead again sa redox process. Next is intergranular corrosion, an attack along the grain boundaries of an alloy and commonly results from a lack of uniformity in the alloy structure. The lack of uniformity is caused by the change that occur in the alloy during heating and cooling or during the materials on the manufacturing process. So with the intergranular, isang material lang or isang metal or non-metal lang tayo nag-occur yung intergranular. However, the question on your mind siguro, sir, based on the presentation, in order for a redox process occur or a corrosion occur, we will have to have two materials po, that is anode and cathode. However, on the intergranular corrosion po, nakita nyo dito sinabi lack of uniformity. So, iduktong ko na siya sa stress corrosion. Kunyari, meron tayong isang material, isang part. So, of course, isang part siya ng aircraft, isang material lang ang ginamit doon. However, dun sa right-hand side nung part na yon, let me have a presentation or a sort of visualization. So we got a component, sorry. Let's have it a rectangle. Pardon my drawing, wala akong mouse at the moment. So ito yung component natin. However, this material or component, itong part na to is naka-joint. So may hinahawakan to. So yung part na to, yung right-hand side ng component is stress. So magkakaroon ngayon, sabi nga, lack of uniformity. So kung itong part na to is stress, so mas nagkakaroon siya ng heating, magiging magkaiba yung stability ng material on the right-hand side. Ngayon, magkakaroon tayo ng lack of uniformity at that certain material. There we go. So if this one is stress, or sabihin natin, lagi siyang, itong material na to, mas nababasa siya, or sabi nga dito, pwedeng sa manufacturing process pa lang, iba yung uniformity. Ngayon, kahit iisang material lang to, i-conclude nung process or nung atomic particles na magkaiba sila. So yung isang part ang magiging anode and yung fresh part yung magiging cathode. Less stable na to stress siya. So ito magiging anode. And ito yung magiging cathode. Kahit parehas sila na material, magkakaroon tayo ngayon ng transfer of electrons to one another. So pag ganun ang electrons, mapunta lagi sa cathode and magkakaroon tayo ng oxidation or pagkasira on this metal. So that is intergranular corrosion. I have a picture later. So stress corrosion, yun, in-explain ko na rin. That is usually on the stress or tensile stresses nag-occur na nagli-lead sa intergranular corrosion. Next is fretting corrosion, damaging form of corrosive attack occurs on two mating surfaces. So si fretting, ito yung nag-occur doon sa mga surface or loaded surface na usually may contact to one another. Hindi man sila may direct contact, but may movement sila or may contact wherein na-speed up yung process ng transfer ng electron or yung redox process natin leading to fretting or tinatawag nating fretting corrosion. Kaya nga, pag nag-inspect tayo ng aircraft, usually ang tinitingnan po agad dyan is kung saan yung mga movable parts. So look into agad yan. So kunyari sa isang general aviation aircraft, yung cables, since ang control surfaces nakakabit yan through cables and pulleys doon sa mismong surface or control surface. Therefore, yun agad yung chine-check. Yung mga dinadaanan ng cable, nagagasgas yan, may oscillation. Yung connection ng cable and pulley, yan, common yan na nagkakaroon ng corrosion, which is referred to fretting corrosion. Moving into our next slide, I have here an example of a surface corrosion. You could see probably due wear and tear. Minsan naman may mali doon sa paint process. So pag may sablay sa painting process, yan, nasisira yung paint which could lead to surface corrosion kasi may expose yung ating object. Next slide, we got here a intergranular corrosion. You could see na same material to, however, nagkaroon tayo dito ng corrosion. So, naiba yung uniformity ng part na to. Because siguro may nakakabit na part dito na hiwalay, may or laging nababasa to or mas heavily stressed to. Kaya meron tayong intergranular corrosion. There we go. We got another example of corrosion. This is stress corrosion. This is a stress part. And that leads to intergranular corrosion. Next, we got here an example of a fretting corrosion on a moving part. Ayan. So, pwede rin mag-start si fretting. Pwede mo rin pa siya i-categorize as surface corrosion. Kasi nasisira yung general or yung cover or paint or whichever cover yung ginawa doon sa material or sa metal, nasisira siya kasi nga nag-oscillate or movable tong part na to. Yan. We could also categorize surface into fretting corrosion. Next slide, we got factors affecting corrosion. We have two written down here. First is climate. Next is foreign material. So climate, it says here exposure to seawater, salt air, or the water itself. So dito papasok yung example nga natin, yung Aloha Airline incident on Hawaii. And compared also to our country. So ang climate or the atmosphere itself, may tinatawag tayong humidity. That is the presence of water in the air. So may mga countries na ang climate same sa atin na mataas ang humidity or humid yung hangin. So may present ng water. Kaya if you compare the temperature on our country compared to other foreign countries, even at the same temperature, mas hassle yung init sa atin. This is because of the humidity. So sa kanila, water as a tropical country. We'll get back into that. Foreign material. So ito na yung dito na kanina yung pinag-discuss natin na direct chemical attack. So we have few example here. Soil, oil grease, pasok pa rin to. Welding, yan, sinabi rin natin to. The chemical joining process, spilled battery, yan, papasok yan sa contact in foreign material. Balik tayo sa climate or dun sa contact sa water. So, marami ang nako-confuse with corrosion to rust. So, ay hindi parehas. So, they are not similar terms. Corrosion po is yung the actual process na nangyayari. Yung rust naman po, process yun. So, pag sinabi natin rust, kaya ito yung mas familiar tayong term, kasi ito yung pinaka-common sa ating everyday life. Ang rust po kasi, it is the corrosion process in ferrous material. So, pag sinabi natin ferrous material, it is material na may contain or meron tayong iron. One example of this is steel. Steel is an alloy of iron and carbon. So, may iron siya. So, doon napaprocess yung rust. And steel po, ang isa sa mga pinaka, let's say, on the materials perspective is much available and less expensive. So, common yan. Pero mataas ang strength niya. So, nagagamit natin yan commonly sa mga gate, sa windows, sa houses, sa cars. Lagi tayong may steel component. And yung orange or brown or reddish na nangyayari doon through time, yun yung tinatawag nating rust. It is the corrosion process exposure to water. So sinabi ko nga kanina sa discussion, in order for it to make sense, we need an anode and a cathode. Ngayon, ito nga pong si iron, kaya madaling ma-form ang rust, is iron is sobrang less stable niya. So, yan, readily available siya, stable siya, mababa ang kanyang stability. And if the stability uh, is lower to another material, then we could have a redox process. Ngayon, ang nobility or stability ni iron is mas mababa sa water. So, doon pa lang may problema na tayo. Kaya si steel or any iron component na material, if na-expose sa water, very easy na magkaroon tayo ng rust kasi mababa ang kanyang nobility. So, babalik ulit tayo sa process na napag-aralan natin kanina. So, let's say we got a material. I'll have it as a rectangle again or a square. Pardon my drawing. So, example, ito yung steel natin. Steel component. Steel is iron and carbon. Ngayon, let's say wala siyang paint. So, kunyari, kinabit mo yung gate mo sa labas, wala pang paint. Nabasa ng ulan. So, let's have a water droplet here. So, wala tayong paint doon sa ating steel gate. So, ang mangyayari, may direct contact tayo with the two material. Walang protection si gate. And sinabi ko nga kanina na si ating iron is mababa ang stability. So, this one will serve as the anode. And the water will serve as the cathode. And then, babalik ulit tayo sa redox process, transfer of electron. The anode will lose electron and will lose mass. So, oxidation dito. And the cathode will gain electron and unti-unti, kinukuha niya yung electron, kakainin, or the anode will lose mass. Dito na tayo magkakaroon ng rust paunti-unti. So, yun. Same process tayo ng corrosion sa rust. However nga, mababa ang stability ni iron, nagkakaroon siya ng corrosion process or redox process sa simple contact ng tubig. So, very important na we kept things dry, away from rain. If may expose naman siya, we paint it, we provide solution available na hindi man may stop yung corrosion, however, mapoprolong yung life ng ating mga steel components or ferrous material dahil sa sobrang baba ng kanilang stability. Next slide, I got here a few example of common corrosive agent. So, unang-una dyan is we got acid. Let me get my laser pointer. So, we got acid. So, nadaanan na natin to kanina. So, acid, example nga niyan, yung mga strong acid like sa battery, present sa battery, halogen, sa mga bulb, yung mga chemical, nitrous oxide components, and organic acid, even na present lang such as on animal waste. This could lead to corrosion. Next is alkalis. So alkalis, they aggressively attack aluminum and magnesium alloys, and they contain corrosion, or they also is a corrosion inhibitor. So, saan ba natin nakukuha ito? Dito papasok yung, remember, we have special inspection indicated on aerial application aircraft. Again, on aerial application aircraft, those are the agricultural aircraft. Example nga, crop duster. So, meron silang mga alkalis component. Two basic example here is yung potash. It's a mineral and chemical, contain potassium. Nakaka-speed up siya ng corrosion process. Ang potash po, yun yung ginagamit as fertilizer. Another example is ammonia. Ammonia naman po, same, nakaka-speed up ng process. Siya naman yung ginagamit as pesticide. So kaya both fertilizer and pesticides are harmful sa ating aircraft. Kaya binibigyan ng pansin yung mga aerial application or yung mga agricultural aircraft. Next is salt. Very self-explanatory. We got atmosphere, water. Atmosphere, of course, pag mas mataas ang ating altitude, mas mataas yung presence ng water or ng moisture. Salt is almost the same with water. However, mas mataas yung component nila to speed up the redox process compared sa water. Kaya if you will look into places near ocean, yung mga metal natin doon still usually corroded kasi mas mabilis yung pag-process nila compared sa fresh water. Next slide, we got preventive maintenance, very important to combat corrosion. So same analogy on our own. So syempre kung ikaw, hindi mo naantayin na lumala yung condition mo. So hindi na natin aantayin na magkaroon tayo ng sakit, then saka tayo pupunta or magpapagmot with the doctor. So same analogy sa aircraft, we have preventive maintenance. So sabi ko nga, wag mo na antayin na magkasakit ka. So if may nararamdaman, di ba, we take vitamins, we take paracetamol, nag-exercise tayo, nagpapahinga, nag-water therapy. Those are preventive maintenance. Sa aircraft, meron din tayong ganon. Preventive maintenance consists on the preservation, upkeep, and the simple replacement of small parts. So, wag hindi na natin naantayin na masira ang isang system or masira ang isang component or part. Or hindi na natin naantayin na magkaroon tayo ng mga accident or incident. So, we provide preventive maintenance also para hindi na natin antayin na magkaroon tayo ng corrosion. So self-explanatory, adequate cleaning, of course, pag nabasa, linisin natin. We remove water content para hindi na tayo magkaroon ng corrosion. Periodic lubrication, maiwasan natin yung fretting sa mga movable parts. The more na nilubricate natin sila, less friction, less fretting corrosion. Detailed inspection, prompt treatment, so of damaged paint areas, sinasabi ko nga kanina, paint is, or the function of a paint is to protect the material on a redox process, not only as a style or mapagandang aircraft. So we touch up damaged paint areas para hindi na magsimula ang corrosion. Drain holes free of obstruction, daily wipe down, sealing of aircraft against any weather, maximum use of protective covers on parked aircraft. So yan, generally, we just prevent, the redox process, keep away sa tubig, keep away with other materials, less friction. So yan, self-explanatory naman with the preventive maintenance. Next slide I got here, slide 15, material safety data sheet or yung tinatawag nating MSDS. I just have here an example of the document. So nadaanan na natin to before. With the corrosion, gagamit tayo, or corrosion prevention, gagamit tayo ng mga products or chemicals na readily available sa market. So marami kasi tayong mga corrosion liquid to prevent corrosion aside from paint. May mga available tayo sa market, and meron din tayong mga liquid component na ginagamit pang tanggal ng corrosion. Later, we'll look into that. However, hindi lahat naman itong mga liquids na to applicable to one another. So, hindi pwedeng porket nag-work siya with rust, with ferrous material, possible na agad na mag-work siya on aluminum or non-ferrous material. So, it's very important na every move na gagawin natin using these chemicals before application with the aircraft is to check the MSDS. So para hindi natin ma-damage yung material. Baka kasi pwede siya dito, hindi siya pwede on this material. So always, have an insight na i-check yung ating MSDS or MSDS ng material. Inspection. So periodically, we provide inspection para ma-prevent, or another example of a preventive maintenance, and to see yung isang part bago pa lumala. So we have your corrosion prone areas. We have discussed this, I think, prelim, same breakdown. Again, exhaust trail areas, sabi ko nga, change of temperature sa exhaust trail areas. So, mainit yung part na yan, iinit, lalamig, iinit, madali nasisira yung paint. Therefore, when paint is done or damaged, material is exposed and it's prone to corrosion. Battery compartment, we have direct chemical attack here from the fumes of the battery. Build bilge areas, that is the lower portion of any object. So, kunyari sa isang aircraft, let me have a presentation. Kunyari, we got an aircraft, front view, so medyo cylinder type. Ang bilge areas are the lower portion. So, dyan, ito yun, yung lower portion ng iyong aircraft. This part. Lagi natin i-check yan. Kasi, for example, we have here a lavatory. Nagkaroon ka ng leak. Ang water kasi is liquid. So, lagi yang gagalaw and subject to gravity. So, lagi yang pupunta on the lower portion. So, lower portion ng, sabihin natin, ng part na to, check mo yung flooring. If medyo basa, wala na, check mo pa rin yung lower portion after that. Kasi ang liquid will always flow and will always subjected to gravity. So, bababa yan. Yan yung bilge area. Next is wheel well, landing gear. When we land an aircraft and we take off, we are subjected to what's this? The correct term, sediment, yung mga lupa, yung mga small stone, mga debris, subjected yung wheel well and landing gear dyan. Ngayon, spinning yung wheel natin during takeoff and landing, thrown away yan on the aircraft landing gear assembly. So, possible tada-damage niya due to friction, nababakbak yung paint. So, prone to corrosion yan. Engine frontal areas, prone to corrosion kasi nagkakaroon tayo ng icing or water present yan. Especially on general aviation aircraft, engines are air-cooled. Okay, external skin areas, very prone to surface corrosion, and some other stuff, self-explanatory for the inspection. And we have already discussed this on the prelim, so let's move on to the next slide. Next slide, we got corrosion removal, slide 17. Self-explanatory also in general, to complete a corrosion treatment. So first, cleaning and stripping of the corroded area. Next is removing as much of corrosion product as practicable. So tanggalin natin yung lahat hanggat maaari. If it's possible to replace that tiny part or tiny component, it's the best way to do it. But if it's not possible, we remove as much as corrosion we needed. Kasi ang corrosion, para po yung bacteria, pag hindi natin naubos, mag-gain yan uli, magkakaroon ng reoccurrence. So it's very important to remove. Neutralizing any residual material remaining in the pits and the crevices. So make sure na thoroughly clean. Afterwards, restoring protective surface film. So very important kung ano yung current protective surface film. Check natin with the aircraft manual kung ano yung nilagay nilang protective coating. Kung may paint, balik natin yung paint. Applying temporary or permanent coating or paint finishers afterwards. So after the surface film, kung meron, kung wala, we go on to the paint. Kasi kahit nilinis natin, tinanggal natin yung corroded part, if we did not cover it back, magkakaroon ulit tayo ng redox process or corrosion process. So it's very important to, or after cleaning it, balik yung protective coatings niya or paint finishes. So in general, the corrosion removal, almost the same lang naman sila. So lilinisin natin thoroughly, we neutralize it, we restore the protective surface or paint finishes. At any given material, almost the same lang yung process. But that is in general. So you could look into our advisory circular AC43. So may mga general process dito. And this is subject lang if wala tayong manual or process given by the manufacturer. Saka tayo mag-look into this advisory circular. Next slide. I got here an incomplete removal of a corrosion product. So you could see here na nagkaroon tayo ng reoccurrence. So binalik nila yung protective film, binalik nila yung paint finishes, as you could see na subject siya sa painting na. However, nagbalik yung corrosion on the painted part kasi hindi siya na linis maigi or na clean. So the one of the most important process on corrosion removal is yung unang-unang step, which is cleaning or removing the contaminated part. Kasi contaminated na yun eh. Pag may naiwan tayo, the cycle will begin again. Moving into our next slide. So with the next slide, mga ways lang natin on how to remove corrosion. We have specifically address your corrosion on ferrous metal. So ito yung rust. Ayan. Rust. Yan yung common tayo. That is one kind of corrosion on iron or iron materials or ferrous metals. Yung reddish, orange, or brown na nag-occur. So with the removal of corrosion, gagamit lang tayo dyan ng mga, commonly used equipment. We got, sandpaper, familiar kayo dyan, or liha. We could use steel brush. We could use abrasive pads. So ito, abrasive pads. I got example here. So yan, abrasive pads. Tapos nakakabit siya sa compressed air, sort of a grinder. So para siyang grinder, pero ang nakabala is yung abrasive pads. If hindi kayo familiar with abrasive pads, yan yung para siyang Scotch Brite yung material. So yung panlinis natin sa plato, yung green portion, so ganun yung itsura ng abrasive pads. So kina-combine siya with a sort of a tool that looks like a grinder or on a grinder. Tapos paikutin siya wherein it could help you buff or remove corrosion or rust on a material. So that's one process. You could also use chemical. We got here Loctite. So Loctite common to na rust dissolver na ginagamit before and especially on the general aviation. So may mga chemical. So sabi ko nga, marami tayong mga chemical readily available on the market. So better check their MSDS first before you could use it. One example, itong Loctite. You could see rust dissolver siya. So hindi siya corrosion dissolver. From the title itself, it is rust dissolver. So technically speaking, ito palang Loctite na to is for ferrous metals lang, for rust, not in general as corrosion. So technically, hindi siya applicable on aluminum. So that's certain example, mga use ng MSTS. Chemical testing. So in reference sa kaninang slide, sabi ko nga, we'll be using mga chemical. So may mga chemical na pwede sa ferrous, pwede sa aluminum, pero bawal naman sa magnesium, things like that. So very important to check yung mga documents natin with the aircraft, SRM, manual, maintenance manual itself, or mga advisory circular from the government or service bulletin from the manufacturer to check if that chemical that we will be using is applicable on the parts or on the material para maiwasan na natin. So kaya nga tayo gumagamit nun to prevent corrosion and damage and gastos. So pagka hindi natin chinek, baka mapunta pa tayo sa destruction or more damage doon sa component or material. Next is corrosion of aluminum and aluminum alloys. So with the aluminum or aluminum alloys, so ganun lang din, we could use chemical, we could use certain materials. So pag aluminum, medyo lighter material to. So ang ginagamit natin dyan is mga light abrasive pads. One example is Tampico fiber brush. So ito yan on the right hand side. So para siyang brush na mas light kung compare natin sa mga ginagamit sa ferrous or sa steel, which could help remove corrosion on aluminum. Another example, mga emulsion cleaner. So counterpart niyan sa ferrous is yung kanina yung Loctite. So may mga version din tayo with aluminum and aluminum alloys, sort of cleaner to remove corrosion. Another example, yung anodizing, skip ko na muna. Process to, hindi to removal ng removal ng corrosion. This is to prevent corrosion. It's a process. We'll look into that later. Another example is vacuum blasting. So with the vacuum blasting, para tong abrasive blasting or sand blasting. So familiar na kayo doon, ginagamit to outside the aviation industry din sa mga pag-repair ng kotse. So ginagamit siya pang tanggal ng rust or even paint. So yung abrasive blasting or sand blasting, high pressure na nagbubuga siya ng sand. Unti-unti niya ngayon ginagasgas or tinatanggal yung part na rusted or yung part na gusto mong tanggalan ng paint. However, the disadvantage of a abrasive or sandblasting is makalat. So natanggal mo nga yung rust or yung paint or that part na linis mo. However, yung sand and yung mga rust na natanggal mo, pupunta lang siya on the other aircraft components, which could lead soon sa corrosion or lead to corrosion din or magasgas yung part na yun, ma-expose, will lead to corrosion. Ngayon, meron na tayo ngayon vacuum blasting. So it's a combine of abrasive blasting and vacuum. So habang habang sinasandblast yung material, meron siyang vacuum process wherein hinihigop niya din yung sand and yung rust or corrosion na natatanggal. So malinis, wala tayong kalat with the vacuum blasting. I got a example nito, vacuum blasting on a aluminum. I'll have a video example on the next slide. However, hindi siya sa aircraft, so I got an example. Pero sa aluminum siya, aluminum tank, yung mga tangke na ginagamit natin sa bahay. So that's aluminum. If meron kayo nung grayish na tangke, pale gray, so that's aluminum. We'll look into that into our next slide. Okay, there you see kung paano nare-remove yung corrosion on a aluminum surface and on a aluminum skin. Next slide, we got corrosion on magnesium alloys. So the process is also the same lang naman. Sabi ko nga, in general, lilinisin natin, remove as much as the affected area. We repaint, we get back to the protective coating. So we got general steps here. You can see on advisory circular 43. That's the previous AC we discussed last midterm. So isa yan sa mga pinakagamit na AC on the maintenance side. And lastly nga, sabi ko, if or you will only lead to that if wala tayong available na maintenance manual or just say aircraft maintenance manual on that specific part. Pero pag meron, of course, we'll look into the manufacturer instruction first. Next slide, we got here protection of the similar metal contact. So we got here a very important table where you could see kung ano ba yung mga metal na mataas ang difference ng kanilang nobility and yung mga metals na almost the same ang nobility and will not lead to corrosion or with the redox process. So you could review and take a look on the table on your free time. Next is corrosion limits. So we categorize it in level 1, level 2, and level 3. Very easy to understand lang naman. Pag level 1, it's within the allowable limits. Level 2, it's outside or exceed the allowable limit. However, hindi siya urgent concern. Pag level 3, it exceeds the allowable limit and is categorized as a urgent airworthiness concern. So level 1 within the limit, level 2 outside the limit, level 3 outside the limit, and a urgent airworthiness concern. Next up, we got processes and materials used in corrosion control. We'll look into this, especially yung electroplating. So ito yung isa sa mga pinaka-common on several parts. Ito po yung ginagawa. So if you look into sa mga local shop, meron tayong mga murang jewelry na gold product. So yung gold-plated, silver-plated. So ito yun, electroplating yung process. Common din to sa mga stainless steel. So pag sinabi nating stainless steel, that is still categorized as steel. So steel, carbon, and iron. And supposedly magraras yan. However, in electroplating sila, ngayon nabalutan sila ng chromium or ng chrome material to protect them with corrosion. Same sabi ko nga with the jewelry you could find at low cost sa mga local shop, steel din yun. So that is ferrous material. Mura siya and matibay. Nagmumukha lang siyang maganda and protected with rust and corrosion or other types of corrosion is with the process of electroplating. So kino-coat siya ng gold or ng silver at a very, very small amount. So how does the process done? With electroplating, same yan with the redox process. So we got an anode and a cathode. So binalik natin yung process ni corrosion sa kanya and we use this process to defend against a corrosion. So pili lang to, yung electroplating. So may mga piling material lang where we could process the electroplating. Kaya common lang is gold. We got common material. Like, let me take a look into that. So for example, we got brass to copper, steel to chrome, copper to gold, and several other materials. So hindi siya applicable sa lahat ng materials yung electroplating. We process it nga with a redox process. So meron tayong less stable material and a much stable material. So yung much stable material, yun yung magiging byproduct natin. So siya yung mag-gain ng mass. Remember, on the process kanina ng corrosion, nag-gain siya ng mass yung material nung kabila na pupunta or nagbabalot sa kanya. So, ganun yung electroplating. Let's take a look on a video presentation para mas maintindihan natin. We go ahead and play it.
In this video, we're going to learn about electroplating. Electroplating is the process of coating one metal object with another used to drive a chemical reaction. We're going to look at why you'd want to electroplate, how it works, and various conditions that need to be considered. So why would we want to do electroplating? Metals may be electroplated for aesthetics, protection, or both. Aesthetics might involve making them shinier or giving it an attractive color by coating. For example, jewelry is often plated with gold or silver. A metal coating can be used for protection, as it may help resist corrosion, rusting, or just general wear and tear. Car rims are electroplated for both shininess and protection. Chromium, commonly known as chrome, nickel, tin, zinc, and cadmium are often used to plate copper, iron, and steel objects. Tin cans are actually made of steel, but have a thin tin coating. Ed White, the astronaut who made the first American spacewalk in 1965, was wearing a gold-plated visor to protect his eyes from the solar radiation. So how does electroplating work? An electric current is passed through a solution that conducts electricity, called an electrolyte. To create this current, 2 electrodes are dipped into the electrolyte solution and connected to a battery or power supply. So we end up with a setup that looks something like this. When the current is turned on, the electrodes gain a charge. The positively charged electrode is called the anode, and the negatively charged electrode is called the cathode. The electrodes in an electrolyte are carefully chosen based upon what metal you are plating with. So if you want to copper plate another metal, you will use a copper-based electrolyte solution and have a copper anode. The copper for the plating comes from the electrolyte solution, which in turn has its stocks replenished by the copper anode. So let's look at copper plating as an example. We want to copper plate some brass. So we have a copper anode, a brass cathode, and a copper-based solution for the electrolyte. So copper sulfate solution. Copper sulfate solution contains blue copper ions and colorless sulfate ions. The copper ions are positively charged and so are attracted to the negatively charged brass cathode. The copper ions deposit onto the brass, producing the thin copper plate. The positively charged copper ions gain electrons, which is known as reduction. The sulfate ions are negatively charged and so are attracted to the positively charged copper anode. The current supplied to the anode causes the copper atoms to oxidize, which is lose electrons, and then dissolve into the electrolyte solution. So the copper ions move from the anode to the cathode in the solution, and the electrons move from the anode to the cathode, but along the wire. The copper anode bar gradually dissolves to replenish the copper ions in the electrolyte solution, so the solution stays at the same concentration. If another metal was used at the anode, then the copper sulfate solution would get paler or less concentrated. So just remember that oxidation, the loss of electrons, takes place at the anode, and reduction, the gain of electrons, takes place at the cathode. So a few other things to consider in electroplating. The speed at which electroplating occurs depends only upon the strength of the electric current. A stronger current increases the speed at which the ions and electrons move through the circuit, speeding up the plating process. One way to increase the current is by increasing the concentration of ions in the solution. It is also important to choose your metals carefully in electroplating. Not all metals will alloy with each other. For example, steel has to be copper plated and then silver plated because it will not form a direct alloy with silver. There are also environmental concerns associated with some metals. Chrome plating, for example, creates waste materials which are dangerous to humans and animals. Waste products have to be treated accordingly to make sure they are safe, which can be very expensive. And finally, most importantly, for current to flow, the ions need to be able to move. So the compound must be molten or dissolved in a solution. So in conclusion, from this video, you should understand how electroplating works using electrolysis. When the current flows, the positive ions in the electrolyte solution move towards the negative cathode, where they gain electrons, which is reduction. And this is what causes the plating to occur. At the anode, the current causes the metal atoms to lose electrons and dissolve into the electrolyte solution. The electrons, which the metal atoms lose, flow back to the power source and around to the cathode. Losing electrons at the anode is known as oxidation. So just remember, we have reduction at the cathode and oxidation at the anode, and that's electroplating.
There we go. So we got electroplating. Another form of chemical treatments you will be encountering to prevent corrosion. So usually if we have paint, it lasted, or it protect 3 to 5 years. Um, then we have to touch up the damaged areas or repaint the material. However, with this chemical treatments, mas mahaba siya. Usually 10 to 20 years ang tinatagal. Una is anodizing. Anodizing is that when a cathode is positioned within the tank and a current passes through the medium, the oxygen reacts with the surface of the aluminum, creating an anodic layer. So bago pa magkaroon ng transfer of electrons, kinukuha na nila yung electrons doon sa anodic material, which is the aluminum. Doon lang sa subsurface nito. So, it creates a anodic layer doon sa surface sa labas. Pero effective siya, tumatagal siya, 10 to 20 years nga with this kind of process. One example of a anodized material, yung mga carabiner. I think I have a picture on the previous slides kanina. So yung mga carabiner na ginagamit natin with the keys and with the alcohol, those are example of an anodized or a anodized aluminum or material. Another example is alloydizing. With this naman, very easy siya, or this is a quick treatment compared with alloydizing, which is hindi na natin kailangan ng specialized facility. With alloydizing, gumagamit lang tayo ng material para magkaroon siya ng chromic acid-based coating that will produce a chrome version coating to aluminum and its alloy. So si steel, meron tayong stainless steel wherein we electroplate a chromium through the material. So meron tayong counterpart ng process na to on the aluminum. However, pinapahid lang natin siya. So very easy. It's a coating, a chemical coating we apply on the skin, which will create or categorize as alloydizing treatment. Next is aircraft aging program review. So with this, nagsimula ang aircraft aging program reviews, sabi ko nga, sa isang, turning point event or accident. Yun yung Aloha Airline incident doon sa Hawaii, wherein na-riff off yung roof ng aircraft or part ng aircraft during the flight due to corrosion na hindi nakita. And these are with age aircraft. So, aircraft are built tough. So, tumatagal siya ng 20, 30, 50 years. Ginagamit siya in service as long as it is still efficient. So, after that incident, the FAA made a aircraft aging program review. So, I'll move on to the next slide for much important details. Self-explanatory naman to. Just read it on your review session. So the important details are on the next slide. Slide 30, last slide for this semester, this subject, and for this presentation today. So aging airplane safety rule. So yung compliance time, And it's for every 24 and 14th year, self-explanatory. Um, Doon start yung additional inspection for aging aircraft. So sabi ko nga, yung Aloha Airline, if I'm not mistaken, 1988, sorry, I don't have the notes on my end. After that, the American government or the US government um, passed a bill regarding it. It's the Aircraft Safety Act of 1991. So this is with the US government. Sorry, I provided FAA. That's an error. After that, 1991, ang na-publish or na-implement pa lang to ni FAA is 2003. As you could see, 2003 pa. Nila na ilabas naman yung document from themselves kasi yung Aircraft Safety Act of 1991 generalize siya. If I look into the law, very general yung sinasabi doon. So parang, kailangan pa ni FAA na magkaroon ng more detailed guidelines. Then, mapupunta kay operator and manufacturer, magkakaroon naman sila ng much detailed guidelines. So, this is the law, the FAA Aging Airplane Safety Rule. Sorry, that is AASR. Mali din yung abbreviation ko dito. AASR. Ito na yung guidelines implemented ng FAA. And afterwards, naglabas sila ng advisory circular number 120-84. Additional information, remember, we provide AC for additional information for the aging aircraft inspection and record reviews. For the year interval ng compliance mo, if you are or if an operator owns aging aircraft na masasubject or subjective with the Safety Act or with the AASR. Okay, so that ends our discussion for today, focusing on corrosion and a few notes with aging airplane safety rule from the FAA. So, yun lang naman, just take note with this time number and with the important details. I will end my discussion here. Let me close my slide and my okay. Any questions so far? Section 4, before I end our session today. Please make sure na understand the process of per NDI and NDT method as discussion, the processes, and for today yung corrosion. So the general information, how do corrosion forms. So any question before I end the discussion or the meeting? Going once, going twice. Okay. Thank you, Carl. So if wala nang question, I'll see you next week. Same schedule as I have mentioned kanina. So Wednesday next week, recitation tayo, both subject, and probably push natin Friday for quiz both subject. Thank you, Section 4. Have a good day for today.
Thank you po, sir.